All right, this video is going to discuss an introduction to video game physics, and we're going to start with simple physics of vehicle motion. This is found in my favorite book, Beginning Flash Game Programming for Dummies, but it's all written in ActionScript 2. So what I'm going to do is this is going to be written in ActionScript 3, and I'm going to show you, this is chapter 12, vehicle motion, in the fuzzy physics section of that book, written by Andy Harris. So let's start with, we have draw a simple car. So this is just a simple shape. Could be a box. I'm assuming by now you've watched enough videos that you know how to manipulate shapes to be anything you want it to be. Draw circles, boxes, add wheels, draw lines, and then when you're done with that, you select the whole thing, and you could either right click, convert to symbol, or you can go under modify, convert to symbol, and turn it into a movie clip. Give it a center registration point, name it what you want, and hit OK. So I'll get rid of this. So the first thing I did was I just drew a simple car, and then I converted to a symbol, a movie clip symbol with a center registration point, and I named it CARR, car, and that's all that is. And then we have our action script. So I created in another video, introduction to game-based programming. We just had a ball and we put motion on the ball, and then we made the ball bounce and wrap around the screen. And we're going to continue with all those same programming codes, but I'm going to show it to you in a linear function fashion. And all we're going to do here is we're going to create a variable, which is a number, and we're going to use a number 3. And we're going to add in a listener event, which is the enter frame. So when we enter the frame, it's going to run this function code called car move, and that is that the car X position, wherever this X dot is going to plus our number variable X move, which is 3, on every time it runs through a frame. And this is 12 frames per second, so it'll go 3 pixels of distance times 12 for every second that takes place. And that's it. That's a simple one. We've done this before. And this is displacement during a time frame. We run it, and you can see that it's moving at a constant speed or a constant velocity from the left to the right, and it'll just continue doing that forever unless we put in some type of stop code, but we're not going to do that. So now car 2, same car, same movie clip, still named car, and we change our code a little bit, and we had an X variable of 3, and we had a Y variable of 2, plus equals car move X. Right? So this is the same thing we did when we created our ball program. If you watch that, control test movie, and we have our X position and our Y position being added at the same time. So that's nothing new, nothing really exciting, just something that we understand. So now we're going to put in a rotation. Okay, so we have our X move variable 3 and our Y move variable 2, and we're going to create a variable named angle. And we're going to use a little bit of trig here. So whatever our number 3 is going to be our X move, and whatever our number 2 is our Y move. And we're going to take that times 180 divided by pi. So we have our anti-tangent, math anti-tangent 2 squared, and we have our Y move, X move times 180 divided by pi. and we're going to call that the rotation. So we're going to rotate that, whatever that number is. So this is nice because whatever we change these numbers to, you'll see, and then we have our same function there. It's going to change the rotation of the car when we come in here. So our car is pointing this way. If we have control, test movie, and flash, it turns that way. All right. And if I want it to go, let's say I want to change this number to 8. All right. And because that variable is in our angle rotation variable, control test movie, you'll see that the car points down. So this, whatever the motion of the car is, the car points in that motion using this simple math formula to make sure that the rotation of the car is at a nice reflection of the speed of the x and y positions, or a resultant position, or the resultant direction that the object is moving in as we do that. So that's a nice code we have there. So now for car 4, we have our starting x and y variables, but we're also going to have an acceleration take place of 2. And we call the variable acceleration, but you'll see why it's acceleration, because we're going to add it to our forward speed, which means that it'll add on top of the addition of the object moving when these are pressed, or backward speed. So we're going to use 2 keys on our keypad, and I already have a video on how to add event listeners for keypads. We have just the up key, which is number 38 on our keypad, and we have the down arrow, which is 40. So that's on our keypad, the 4 arrows, up, down, left, right, in the bottom right corner of your keyboard. And we're created these variables Boolean, and because they're not pressed when we start this, we run this clip, it'll be false, right? So it'll be false. Boolean means it's either true or false. So a key is either pressed or it's not pressed. If it's pressed, it's true. If it's not pressed, it's false. So it can only have 2 states. So we create these names for these variables of these keypads, our up arrow and down arrow, and we use the same angle variable that we created with our math equation, so that the car rotation, or the car movie clip rotation, is equal to our angle equation, which is equal to whatever numbers we have in there, which we have 2 and 2. And we add our keyboard events, our key pressed up and our key pressed down. Our key pressed down is if they're true, we press the keys in. The event, the keyboard, code 38 is the up arrow, and if that's pressed in, that's true. Or else if the code 40 is the down arrow, if it's pressed in, it's true. And with the pressed up, that means it's released. You can name it anything you wanted, but we have to call out these event listeners when we write it in here. We write that piece of code in there, so it runs those functions. And that's when they're false. When the up arrow is released, or it's let go, it's false, and that's number 38. And the down arrow is number 40, and when that's released, it's false also. Now, when it's true, when the up arrow is true, our x move is going to have the addition of, so our variable x move was 2, and it's going to be plus, so it's already 2 plus another 2. So it's going to be 2 plus 2 is 4, and then our x move will be 4, and then we add another one, and it'll be 2 is 6, so it'll continue to increase at an increment of 2. So we had our move being that it would move a distance of 2 pixels for every time it runs in the frame, but if we also add our acceleration in the x and y, then it will increase even faster, at a faster rate. So the speed will increase, which is acceleration. And if the down arrow is true from our being pressed, then it will be negative acceleration. We could have done this two ways. We could have had minus equals acceleration, or you could have plus a negative acceleration, a negative number. So adding a negative is the same as just subtracting to begin with. So we just wanted to see that this is positive acceleration and this is negative acceleration, which is commonly referred to as deceleration or acceleration in the opposite direction. And then we have to add that our x location when we have our car move, automatically the x will add 2 for the x position and 2 for the y position, because way over here we said that our variable x move is equal to 2 and our variable y move is equal to 2. Acceleration is an additional 2 on top of that 2 for as long as the key is pressed. It continues to add that, changing the x move, which down here makes it move faster and faster and faster. So let's run this. So this will give us acceleration. So we test movie in Flash, and automatically it moves +2, +2, +2. If I start pushing the down arrow, it goes backwards, and the up arrow goes forwards. And I can make it go, so I'm pressing the up and down arrows right now, and it can go faster and slower and faster, slower and faster. So I can just continue to press this, and I'll keep doing that. So we'll get rid of that. So that's great. Let's take a look at let's take a look at this. What we're doing here is we have our dx and our dy components, and we're actually going to find the resultant using this calculator. All right, so in the angle that it has, or the angle theta. So I created a button, just like I showed you before. We have you can create any symbol. All right, so you create a shape, and then you select it, and then you can either go modify, convert to symbol, or you can right click and do that. And then instead of a movie clip, you turn it into a button, you give it a name, center registration, and boom, you're done. So let's get rid of that. All right, so cut this out. So what we have here is we have this is static text dx, static text dy, static text angle, static text length. And then we have our input text, and we use device fonts. We embed our font that we chose, Times New Roman, and we're looking at the instant name of dx_txt for the text for dx, input text. We have input text dy_txt, and then over here we have dynamic text angle_txt, and here we have dynamic text length_txt. We have our device fonts. We have it embedded already. And we'll Windows Action Script. You can hit F9. You can all right. So we have our calculator button, which is this right here. We named it BTN calculator, and we have a mouse event. And mouse up is when you click and then release the mouse. We could also turn it into a click event. It doesn't have to be a mouse up event. And we have find vectors is what we're going to name the function. All right. And so we have our find vectors function, which is a mouse event, and void because nothing happens when you start until you do something. And we're going to take whatever is in our input boxes, all right, and we're going to change them into variables called dx and dy, and they're going to be number variables. And we want, instead of the string that we enter here using our keyboard, we want them to be integers or numeric integers. So we're going to change them into integers. So the text that we enter, which is numbers, is going to be changed into integers, numeric integers, to be number variables. And then we're going to take our we're going to create a variable named radians, which is a number variable, and we're going to take our antitangent dy number over the dx. So what do we have over dy divided by dx? And then we're going to have a degrees. We're going to find the degrees of that from the radians times 180 divided by pi. Math.pi is pi, number 3.14. with the calculator, rounded off, keeps going for long. And if our dx is less than 0, then we're gonna make it a negative number, which makes it kind of positive number. So we'll get a positive answer. So we're gonna make a minus 180. Okay, so if it's less than 0, it's minus 180. Angle underscore text, which is what goes in this dynamic text box, is going to be the string of the degrees, and our resultant variable, which is a number, is going to be the math square root of so c squared equals c squared equals a squared plus b squared, or c would equal the square root of dx squared, dx times dx, plus dy squared, dy times dy. So we have c squared equals a squared plus b squared. So to find the resultant, we have the square root of our dx, which we already turned into a number variable up here, and our dy, which we turned into a number variable here. And then that number is going to be turned into a string to come out in our dynamic text box length. So this is good for all those physics students out there who are struggling to find the resultant and the angle of their physics equations. You can place any numbers for dx, dy in here, or even if it's forces, your x component and your y component can go in here, and then you can determine the angle and the length and the resultants. Let's see, so test movie and flash under control, and say so I have a dx of 60 and a dy of 55, and I calculate, and I get my answers. My angle is 42.5 degrees, and my resultant is 81.394. So if you're struggling in physics, in high school physics or college physics, and you create this simple resultant calculator, you can determine the angle and the length of forces or any type of two-dimensional motion by using the x component and the y component, placing it up here, and then hitting the calculate button to find the resultant, which is the length, or this could be the resultant length for distance, but it would be a resultant for force, and then our angle theta would be displayed here. So that's nice and simple dx dy calculator. Look at our car vectors here. Alright, so here once again is a movie clip, car, nothing fancy about it. But what I'm going to do here is I'm going to have my up arrow, down arrow, right, and left arrow keyboards. I'm going to add the keyboard events for key pressed down and key pressed up. I'm going to create these keyboard variables like I did previously in a video on just keyboard events by naming the variables. Left arrow is a Boolean variable, and it starts false because it's not being pressed. Variable I'm going to name right arrow is Boolean, is equal to false. Variable up arrow is false, and down arrow is false. We're going to start with a variable, our car.speed and our car.direction. So the speed is going to be 0, and the direction is going to be, we'll name it 33. And then we have our dx, which is our displacement in the x position, and our dy, which is our displacement in the y position for each frame. And we're going to start at 0, 0. So when we go here, the car is going to turn to a rotation of 33, and because we're going to call that out in our function later. But it's going to have a speed of 0, and it's going to have a dx, displacement x, and a displacement y of 0. We have to put in our keyboard events, and then we have a check keys, enter frame, add event listener. We have a car move that makes the car move, enter frame. So let's take a look. We have our key press down function that we named right here for our key down event, keyboard event, and it's a keyboard event. And when 33 or 37, key code 37, which is our left arrow on our keyboard, is pressed, that's true. Then this event takes place. If the key code 39 is pressed, the right arrow, then that's true. If 38, which is the up arrow, is pressed, it's true. And if the key code 40, which is a down arrow, is pressed, it's true. Okay? And then if it's released, so it's pressed up, but if it's released, then it's false. The same thing. Our left arrow 37 is false if it's released, 39 is false. So remember, a Boolean, two states. We have pressed in, which is true, and released, which is false. So we have those, and then we have our function car move, which is an event, and it's an enter frame event. So we have car move is an enter frame, and check keys is an enter frame event. So when we enter the frame, it's going to run the function turn car and move car. We're also going to enter the frame, we're going to run the check keys. So our check keys is if up arrow is true, then the car.speed adds 1 for every frame that it's still pressed. And if the car speed is greater than 25, then it'll equal 25, which means you can't go faster than a speed of 25. If down arrow is true and pressed, then our car speed is negative. And if the car speed is less than -5, then the car speed will stay at -5. It can never go less than -5. And if the right arrow is true or pressed, then the car direction is going to be plus equals 5. So we started with 33, and if you press the right arrow, it's going to add 5 to the car direction. When it gets to 360, it goes right back to 5, and then starts over again. If the left arrow is pressed down, then the car direction is going to be minus rotation, -5. And we're going to, right here where we have that our car move, we're going to call out that the car dot rotation equals the car direction. So our car direction is going to equal our car rotation, which means it's basically going to be the same thing. So we have a car turn, and the car turn is our car direction -90, numbers variable. We're going to call it degrees. And the radians is going to be degrees divided by 180 times math pi. Okay, and the car dx is going to be math cosine of the radios, and the car.dy is going to be math dot sine of the radians. So car.dx is a number variable, and car.dy is a number variable, and the car.dx is going to be times the car speed. So whatever the car speed is going to be, it's going to be multiplied to equal the number of the car dx, and the dy is going to be times equals the car speed also. We have our car move function, and that's so we've called out here what our car.dx is going to be numerically, and it's going to move because the car.x is going to be adding the car.dx for every frame that it enters, and the car.y is going to be adding the car.dy for every frame that it enters. Car rotation is equal to car direction. If the car.x is greater than stage width, then the car.x equals 0. So what we're going to do is if it goes all the way to the right, it comes back to 0 over on the left. If the car.x is less than 0, it's going to go all the way to the right on the stage width. So we did this with the ball wrap demo. So when you go up, you enter from the bottom and continue. When you go to the left, you go to the right. If you go down, you come from the top. And that's all shown if the car.y is greater than the stage height. So when the car.y gets greater than this, it appears on top. If the car.y is less than 0, it appears down at the bottom stage height. All right, so let's now we know all that code. Let's test it out in Flash. And I'm using the 0. So you can see right away it's rotated 33. So it's rotated 33 degrees because the direction we put out here was 33. Now if I press the right arrow, it turns right. If I press the left, so that's +5 rotation, and that's -5 rotation for each of these. Okay? And if I move the forward button, so I have the up button, it goes forward and accelerates. If I do the minus button, it goes backwards, but it only, remember, we have a maximum speed that it can go at. All right, so we have a maximum speed forward, and we have a maximum speed backwards. And when I press two keys together, I can get it to rotate to the right or to the left. So now that it actually has a speed, I don't have my finger on the button anymore. If I push the left arrow, it turns left. If I push the right arrow, it turns right. All right. If I hit the back arrow, it starts to slow down, go backwards. And I take my finger off the key, so I can go forwards. And I can try and, there you go. And I can park it, have no fingers on the key. So you can go ahead and play around with that. Remember, this is just a car movie clip that I've been using the whole time. So let's take a look here, and we're going to have the concept of friction added on here, which is 0.45. So we have our speed, our direction, our dx, dy. We have our code over here. This is a car. All right, and what I have here is this is all static text: drag, power, turn, brake, speed. All this is static text up here: direction, dx, dy. And then over here, this is actually input, so I can change these numbers on the fly. This is drag, input text, use device fonts, embed Arial, power. Oops. Turn rate, brakes. This is dynamic output text. The speed underscore text will be output. The direction underscore text. Remember, use device fonts, embed Arial. It's already been embedded. Our dx underscore text and our dy underscore text. So everything in red here is input. Is static text. These top boxes are input text boxes, and these bottom are dynamic output text boxes. And this is still just a car movie clip. I just made it a little bit smaller. So let's look at the action script we have here. So we have our keyboards that we just used in the last one. And we have our car speed equals 0. Change this car direction to 0, which means it'll be facing upwards when we start. Our car.dx is equal to 0. Our car.dy is equal to 0. And then we create these variables. Our car D angle is a number variable equals 0. Our car drag, car power, car turn rate, car brakes are all variables that we create, and we're going to use whatever's been placed into these text boxes, the drag text, the input text box, the power input text box, the turn rate input text box, the brakes input. And we're going to turn them all into numeric integers, and we're going to turn them into variables. So whatever gets entered in this input text box, which we start with those numbers and we can change them, will then be used. So we could change the power and the turn rate to make it turn faster or go speed, or we could add the brakes, the stops faster, or we could add friction, more or less friction on it. We have our keyboard events that we're going to use, our press up and press down keyboard events. We have our enter frame to check the keys, and then we have our enter frame function car move. So all our functions are named out over here. And of course, once again, our press down for left arrow, right arrow, up and down arrows, all true, all the numbers. Same thing we've been using every time. You'll use it every time that you use keyboard events. And then we have our false, or when it's released, our key pressed up, or it could be called key released. And we have our numbers, and they're all false Boolean variables. Our car move, we're going to have a turn car and move car like we did before, but we're also going to have a function called the get numbers to get these numbers over here and use those. All right, so the first one is our get numbers, and it takes all of our input text box, and down here, I'm sorry. It takes it takes all of our output text, and it turns them into strings so that they can be displayed down here on the bottom. So we have our direction text, our speed text, our dx and our dy dynamic text boxes, and it's going to take all our all the numeric variables that we create in our program and turn it into output for us to see on the side. Our key, our check key, so our car.speed is going to be plus or equal the car power that we have up there. And if we have the down arrow, it's going to be the brakes. All right, so where we have the brakes is going to be that numeric event, and it's will be equal to whatever number we want over there. So our right arrow will be the turn rate, right? Our car direction, of course, our car direction is going to be equal to our car rotation, and we have our car dot direction is minus our car turn rate. So whatever we have over there for turns. So this is the same numbers we had in our last. Right, and then this is all the same we had in our last program there, except we have our car drag for a new variable called the temp drag. We can name it anything we want. We have the same dx car speed, then we have the same move that our car x is equals to car dx. Our car dot y is plus equals car dot dy. Car rotation equals car direction, and then we have our same wrap around the screen code for the x and y position so that it can continue. So it's control and test movie and flash. Alright, so here we have our direction is 90. You can see my direction moves as I press the right key. It becomes greater. As I press the left key, it becomes less and less. Well, then goes to 360 and wraps around again. So our speed is, if we start moving, see there's speed of 1. Right, it goes up. Here's that problem we're having with our dy output. Backwards is our brake. It take away 1, but it can't go any greater than 1. So I can change this to, why don't I change this to 7. And now go forward, go backwards. You can see that's greater than it was when it was 1. Turn rate, you can do 10. Alright. So there you go. And now the DY is working. Very good. And that concludes the first part of video game physics with simple vehicle motion. Next part we will be talking about cannons, projectiles.